Hi, so today we're going to look at formulas and names with polyatomic ions. Polyatomic ions are all those ions you had to memorize, such as nitrate, sulfate, phosphate, and hopefully you've been studying hard and you know them all by heart. What do we do when we put them into formulas or names? That's what I'm going to show you here. So first of all, if we have a name, we want to turn it into ions. Like I've got written down here, from a name to ions, and then I can get a formula. So sodium, I know from the periodic table, group 1, that it's Na+. Sulfate, I know because I've been studying hard that it's SO4 2-. Make sure you know your charges and your subscripts. And then it's just business as usual for the ions. So I take the 1 here and the 2 here, and I cross that down. I get Na2, SO4, and I only have one of those, so I can just write it as SO4. And that is the formula for sodium sulfate, right there. Let's look at the next one here, aluminum carbonate. So aluminum, I know because it's in group 3A on the periodic table. It's aluminum 3+. Carbonate, you know because you've been studying, is CO3 with a charge of 2-. So again, I'm going to take the magnitude of the charge, the 3 and the 2, and cross those. So I have Al2. Notice I'm leaving off the charges when I write the formula. And then I have this carbonate here, CO3. CO3 comes in packages of CO3. So I need to keep carbonate as a package deal, and then put it in parentheses. And the 3 that got crossed over here from aluminum goes outside here. So I'm saying that I have 3 carbonates and then 2 aluminums, and that is your answer there for aluminum carbonate. So if we have a formula and we want to get a name for it, we're going to use our same ionic compound naming rules. We're going to use the same relationships we just did before, but instead of going from a name to a formula, we're going to go from a formula to a name. So if I needed to get charges here, I could take my subscripts and cross them up. This is a 1 here. And that would tell me that I have calcium 2+, and then nitrate, which is NO3, comes out of its bubble and has a -1 charge. I don't actually have to do that to solve this naming problem here, but if I do, it makes it very obvious how to name it. I'm going to name that first metal cation just with its entire elemental name. And then the great thing about these polyatomic ions is I don't have to change the name at all. So this ends up being calcium nitrate. So there you go. We can take a name and turn it into a formula, and we can take a formula and turn it into a name, even with polyatomic ions. Thanks for watching.